Hi, I'm Ellen Stofan, also known as Dr. E.
And I'm Thomas Zurbuchen, also known as Dr. Z.
And welcome to another episode of EZScience. We're here at the Smithsonian's National Air and Space Museum, standing in front of the backup mirror to the Hubble Space Telescope. But we're not here really to talk about Hubble. There's another big launch coming up.
We're talking about the launch of the James Webb Space Telescope. Many people have talked about it as the next Hubble, because Hubble has been transformative in our understanding of the sky.
And it's fun to be here in front of the backup mirror for Hubble. And so for people who are wondering, why doesn't this thing actually look like a mirror? It's the backup mirror. It's two plates of glass that are about an inch thick with that supporting structure in between. And if it had launched, it would have been coated in a reflective material, so it would have looked more like a mirror. These telescopes use these big mirrors to collect light, which then go into an instrument. So spectrographs are really cool instruments, and they've been used in astronomy and astrophysics for over 100 years.
Spectrographs, of course, having the ability of splitting up the light and looking at the composition of light and actually the originator, whether it's what gases is and so forth. And frankly, spectrographs are also here in the museum, right?
In fact, we have over 100 years worth of spectrographs here at the Air and Space Museum. In 1929, Edwin Hubble actually used a spectrograph to determine the fact that the universe was expanding. We have a spectrograph from the Hubble telescope at the Palomar Observatory in California that was used from the 1950s to the 1970s to look at the redshift of galaxies, of white dwarfs, and that helped us again understand the expansion of the universe. But I'm really fascinated with this issue of using a spectrograph to really understand what materials things are made of, how are they moving, and really just collecting that light, which James Webb will do from very early in the history of the universe.
So if you compare Hubble with Webb, there's really two fundamental changes. The first one is, if you look at the mirror, this is 2.4 meters. It's like this, kind of roughly kind of my height. You look at a Webb and it's unfolded, it's 6.5 meters. It's like 3 of me or more, right, with the hand up. So the other thing that's really exciting, the light that we're looking at is actually much, much colder.
And this idea that this super cold temperature and collecting this light with this big mirror is actually allowing you to look back in time as much as 100 million years after the Big Bang, which in the history of the universe, over 13 billion years, 100 million years is really soon after the Big Bang.
Recently I looked at the album of one of my children's, with all the pictures, and I imagined, suppose I didn't know about the first year, what I would miss about the story of my child. It's now in college. And I think of the universe that way. We have not seen those pictures.
Yeah, like one of the questions I've always found the craziest is this issue of black holes at the centers of galaxies. Right now, pretty much every galaxy we've looked at has a black hole at the center. And so we are really curious about these very early galaxies. Did they already have black holes? Did black holes come later? Do you start with a black hole? Like, how does that work? And that's one of the questions that JWST is really going to go after. And we're actually going to be able to use JWST to start looking at the composition of atmospheres of planets around other stars. And that's really critical in this issue of, are we alone?
Absolutely. Looking at especially cold atmospheres and kind of stars that are there, we can see molecular components, things that relate to life here on Earth, oxygen and so forth. Could you just imagine that? We're about to open that door.
And what I think people don't necessarily appreciate is the way we've had to push technology to get to this point.
Absolutely. And that's the beauty of doing amazing new science. We develop new technologies. So consider this technology that was used to shape the mirrors correctly. That technology right now is being used by eye surgeons around the world. That's just one of the many benefits that come from a development like this.
So exciting, and I wish I could be with you at the launch, Thomas, but it's a little bit far away. And so can you tell us where the launch is?
Yeah, it's from French Guiana, a town called Kourou. It's right at that coastal community there where the European Spaceport is. We'll fly on an Ariane 5 provided by the European Space Agency. The Canadian Space Agency also provided an instrument here. So we're excited and ready for it.
Just like Hubble, JWST is going to help us rewrite textbooks for years to come. Stay tuned, watch for the launch of the James Webb Space Telescope, and stay tuned for another episode of EZScience.